Hey guys, today we're going to look at factoring into two binomials. And basically what this is going backwards in FOIL. So if you look at this example at the top, we says we know to multiply two binomials, we multiply using, we say FOIL, that we're really doing four multiplications, and we end up with x squared plus, and then you do 3x and 5x, so that gives you 8x, and 3 times 5 gives you the 15. So if you look at this answer, you get a middle term of 8 and a constant of 15. And if you look at these numbers over here, 3 and 5, they have a sum of 8 and a product of 15. So these two numbers will always end up giving you, the middle will always give you the sum of these two numbers, and the constant at the end will always give you the product of these two numbers when a is 1. So a is, if you refer down here to this formula, you'll notice that all products of two binomials end up giving you this formula of ax squared, so something x squared, plus something x plus bx plus a constant, which we call c. So when a is 1, when this coefficient here is 1x squared, like it is here, you'll notice this pattern and this formula. So we use it to factor. So if you look at example 1, you can easily see that 10 and 7 come from 2 and 5. 2 plus 5 is 7, and 2 times 5 is 10. So this is g plus 2 times g plus 5. Now, I'm going to go through it a little more slowly and just kind of show you how to do this when you can't think of the numbers like off the top of your head like that, and when the signs becomes a little bit more complex when they're not both positive. So if you look at example 2, a more step-by-step way of doing this is you go to the constant and you list factors of that number, like what multiplies to make 30, and try to stay organized. 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now, you need the two numbers to have a sum of 13. So 10 and 3 add up to 13. That tells you that you're going to set up two binomials. A times A gives you the A squared. 3 times 10 gives you the 30, and when you add them, you get 13. Now, if both of these middle signs are positive, then in here, you'll have two positives. We'll get into more complicated ones in a second. All right? So looking at example 3, you'll notice that we're starting to look at something a little more complicated, and that is you have a positive over here, but you have a negative in the middle. So what this tells you is the positive over here tells you that the signs are the same. They're either both, same signs, they're either both positive like you had up here, or they're both negative. Now if you look to the middle in here, that middle term being negative tells you that both signs are negative. Because when you multiply a negative times a negative, you'll get a positive 42. But when you add a negative and a negative, you'll get a negative 17. So I'm going to go through the steps as if I don't know what the numbers are going to be. And I'm just going to go, okay, factors of 42. 1 times 42 is 42. 2 times 21 is 42. 3 times 14 is 42. 4 doesn't go in. 5 doesn't go in. 6 times 7 is 42. And I'm looking for the pair that has a sum of 17. Well, 3 plus 14 is 17. So what I'm going to do is I'm going to set up my two binomials. D times D is D squared. 3 times 14 is 42, and they add up to 17. I'm going to put my signs in last. I always like to do that last. So again, both are the same, but both are negative. So minus, minus at the end. It's kind of easier to just handle the signs at the end. Okay, now, remember yesterday we learned about GCF. If you tried to use GCF here, you can't. If you look at example 4, for instance, or any of these examples, you won't come up with any common factors. You won't, except for 1. 1 goes into everything. And this structure that you see is what we see in the formula up here. Ax squared plus bx plus c. So something x squared, something with a variable, and then a constant. That tells you that this product came from a FOIL problem. So for the example 4, I would look to my numbers and say, okay, what are my factors of 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. I need a pair that has a sum of 15. Well, 3 and 12 add up to 15. So I go x times x is x squared, 3 times 12 is 36 and adds up to 15. Now I look at my signs. This tells me that the signs are the same. The middle tells me they're both negative. So I put a negative on both of them. And it works out because negative 3 times negative 12 is positive 36, but negative 3 plus negative 12 is negative 15. All right, now moving on to examples where the negative is at the end. When the negative is at the end, this tells you that the signs are different. When the signs are different, remember, like with integers, if you're adding like negative 3 plus 5, you're not really adding them, you're actually subtracting them. So when you go through your factors of 27, 1 times 27 is 27, 3 times 9 is 27, you're not looking for numbers that add to 6, you're looking for numbers that technically subtract to 6. So 9 minus 3 is 6. Now the sign of the middle number is going to be the sign of the bigger number, or the number with the bigger absolute value. Think about when you're adding integers, if you're adding a negative and a positive, right, and you're subtracting, then your final answer takes the sign of the number with the bigger absolute value. So here I would need a negative on my 3 and a positive to go on my 9 on the bigger number, so that when I add these I get positive 6 for my sum. So I'm going to say that the bigger number, really the absolute value, bigger absolute value, gets that sign in the middle. So when I set up my FOIL, it's going to be m times m is m squared, 3 times 9 is 27, and I need a difference of positive 6. So the positive goes to the 9 and the negative goes to the 3. Okay, why don't you guys try example 6? You can pause the video. And I'm going to go over it. So factors of 18 are 1 times 18, 3 times 6, 2 times 9. I got a little bit out of order there. And I'm looking for a difference of 3. Well, 6 and 3 have a difference of 3. So I'm going to set up my two binomials. P times p is p squared. 3 times 6 is 18. So this negative tells me the signs are different. And then I look to the middle. The bigger number is negative. So I give a negative to the 6 and a positive to the 3. So that when I add them, I get a sum of negative 3. But when I multiply, I get a product of negative 18.